Hello students, this is a video lecture on section 7.5, Proportions in Triangles. Today we're going to learn to use the side splitter theorem and the triangle angle bisector theorem. So let's jump right in. Our first theorem, theorem 7.4, is the side splitter theorem. It states that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So here we can see we have line RS, which is parallel to line XY. And the theorem tells us that XR over RQ will have to equal YS over SQ. So let's take a look at a proof of this theorem. I'm going to complete this as a two-column proof, so I'm going to have statements and reasons. As is always the case, I'm going to start with a given, triangle QXY, with RS parallel to XY. And as always, that's the given statement. If we think back to the chapter on parallel lines, we can see in this case we get some very special relationships. We have this relationship right here between angle 3 and 1. That distinct F shape tells us that those are corresponding angles, and if we remember, corresponding angles are congruent. So in this case we have angle 3, which is congruent to angle 1. In addition to that, if we look over on the other side of the triangle, we have that same relationship between angle 4 and angle 2, so we can say that angle 4 is also congruent to angle 2. So in this case we have two statements, and they're both made by the corresponding angles postulate. Because of that, and something else that we picked up in chapter 7, we can say that those two triangles are similar. We can say that triangle QXY is similar to triangle QRS by the angle-angle similarity postulate. So we've now proven that triangle QXY is similar to triangle QRS. Since we have similar triangles, we know that their sides are proportional. So in this case, I'm going to state that QX over QR has to equal QY over QS. And the reason I'm able to make that statement is because sides of similar triangles are proportional. Now here we're going to use segment addition postulate. So now I'm going to write the top of these two ratios in two separate parts. Rather than having the top of this written as QX, I'm going to write it instead as QR plus RX. And the second one, rather than having QY, I'm going to write this as QS plus SY. So I've split the top using segment addition postulate. And finally, if I think back to the third property of proportions, the third property of proportions allowed me to add the denominator to the numerator of each ratio. So by reversing the third property of proportions, I can get rid of the QR because that's the denominator, and I can get rid of QS because that's the denominator of this fraction. So I end up with Rx over QR equals Sy over Qs. And since order doesn't matter, a quick rearranging of the letters gives us Xr over Rq equals Ys over Sq, which is what we were looking to prove. And again, the reason for this final statement is property of proportion number 3. So here our first problem asked us to use the side splitter theorem. And if we go back to what the side splitter theorem actually says, it says that if we take the parts of one side in ratio, it's going to equal the parts of the other in ratio. So we can take the top here, which is A over A plus 4 in this case, and that's going to have to equal 12 over 18. So we can say top over bottom equals top over bottom. Cross multiplication here gives me 18 times A, which equals 12 times A plus 4. Both coefficients have a factor of 6, so I'm going to write this as 3 times A equals 2 times a plus 4. So we take 3a, which equals 2 times a plus 2 times 4, which is 8. That's the distributive property. Subtract 2a from both sides, we get a equals 8. So additionally, there's a corollary to this theorem, and it states that if 3 parallel lines intersect 2 transversals, then the segments intercepted on the transversals are proportional. So you can see here I've extended the lines so that we can see the triangle shape that we're dealing with. In this case, rather than dealing with one line that cuts across the triangle and separates these parts into proportion, we have multiple lines that separate the triangle. So here we can see that this part AB over BC equals WX over XY. So a very similar type of question. Problem number 2, we have 3 campsites shown below, and it asks what's the length of site A along the river. So in this case, rather than looking at the picture like this, I'd much rather have it turned sideways. By looking at the picture like this instead, we can start to see the triangle shape that we're expecting to see. And then the proportion gets a little bit easier to establish. We have 9 over 7.2. So 9 over 7.2 is going to equal, in this case, the missing length over 8. So I'm going to call that value x and put that over 8. So cross multiplication, we have 7.2 times x equals 9 times 8, which is 72. And dividing by 7.2, we find x equals 10. Since this is a length, we should include units, and so site A has a 10-yard frontage to the river. The second question asks, what's the length of site C along the road? So in this case, we're looking for this value, so we'll call it y. We can say that 7.2 over y is going to equal 8 over 6.4. So you can see these proportions aren't super difficult to set up. They actually look exactly like they do in the picture, as long as the picture is oriented properly. So cross multiplication here, we have 8 times y, which equals 46.08. And dividing both sides by 8, we get that y equals 5.76. And again, since this is a length, we should include units. And so y is 5.76 yards. And so we have our second theorem of the lesson, the triangle angle bisector theorem. It states that if a ray bisects an angle of a triangle, then it divides the opposite side into 2 segments that are proportional to the other 2 sides of the triangle. So here we can see that CD, this part of the segment, is to its shorter part as the longer leg is to the shorter leg. So longer part of the opposite side is to the shorter part of the opposite side, as the longer leg is to the shorter leg. I remember this theorem slightly differently. So let's identify some of these segments with letter identifiers. So let's call this A, B, C, and D. So we have CD, which is A, over DB, which is B, and that equals CA, which is D, over BA, which is C. By using the second property of proportions, I'm going to switch D and B. So we have A over D, which equals B over C. And then finally, I'll use the first property of proportions to flip this over. D over A equals C over B. This is actually the version I like to use, because if we look at the picture, I can just say D over A equals C over B, which makes these questions relatively easy to set up. You rotate the picture so that the angle being bisected is at the top, and then just separate the 2 parts by a fraction bar with an equal sign in the middle. Let me show you what I mean. So using the triangle angle bisector theorem, we're asked to find the value of y. The first thing that I do is I make sure that the vertex angle being bisected is at the top of the picture. Then I simply separate these 2 numbers with fraction bars and put the equal sign in the middle. So the proportion is y over 9.6 equals 24 divided by 16. Cross multiplication gives us 16y equals 230.4. And dividing both sides by 16, we get y equals 14.4. So in this case, the value of y is 14.4. And that concludes this video lecture on section 7.5, proportions in triangles. At this point, you should be able to use side splitter theorem and the triangle angle bisector theorem. Thanks for your attention, and I'll see you soon.